Hey, welcome to the AI Genie YouTube channel again. In part two, we ran through clustering machine learning model and then the association rule mining learning model as part of unsupervised machine learning model or type. So, in this part, we are going to continue running through the rest of the unsupervised learning model algorithms. So after clustering and association rule mining type, we are going to talk about anomaly detection algorithm type. So as this name of this algorithm suggests, anomaly detection is all about deducing unusual data pattern. It's all about analysis of the data so as to visualize the dissimilarity and to identify the data points that won't align. So, various algorithms can be used depending on the nature of the data and the specific requirements of the application. So, some of the popular machine learning algorithms that suits anomaly detection type is isolation forest. It's actually a learning method that builds an ensemble of isolation tree structure. It works by randomly selecting a feature and then randomly selecting a split value for that feature to isolate anomalous elements in the data. Another type of algorithm that fits into anomaly detection uh, type is one class SVM. SVM stands for support vector machine. So this type is trained only on the normal data and aims to find an aberration or a plane that separates the normal data from the rest. And this type is quite useful when there is a limited amount of training data for anomalies. As I said, it's all about identifying unusual patterns or outliers in the data, which can be indicative of potential issues of interesting events. In real life, we can call out a few prominent examples. One is the most prominent one is fraud detection in financial institutions. So, banks and financial institutions use this type of machine learning type that involves anomaly detection to identify unusual patterns or outlying patterns in the transactions that are being made day-to-day basis. So these anomalous patterns may indicate a fraudulent activity or any other suspicious activity. It might show unusual spending patterns, change of locations in an unreasonable amount of time frame, or large transactions which bank might want to get alert over such transactions or over such volume of transactions for further investigation. Another prominent example would be a network security. So, when this algorithm gets applied, it will identify abnormal behavior in the network packets traffic. It helps in identifying unauthorized access, unusual level of data transfers, or any suspicious activities that may indicate potential cyber attack or malware attack. And it also this kind of algorithm also quite get widely applied in quality control section of the manufacturing industries. So in manufacturing, this anomaly detection can be applied to monitor the production process and identify defective products. Any deviation from the standard manufacturing process or product configurations can be flagged for further inspection. So this is all about anomaly detection algorithm learning model. And next comes the auto recommenders in under unsupervised learning model. So as users interact with any system more and more, uh, this kind of algorithm learns and adapts to provide even better recommendations based upon the historical data, and the correlation lies in between those data. So this kind of learning model leverage algorithms to analyze user behavior, their choice and preferences and patterns to make personalized recommendations, especially in the field of content generation or content presentation. You can see something called collaborative filtering, or user-based collaborative filtering, or item-based collaborative filtering, or even content-based filtering itself. Let's see one by one. So in collaborative filtering method, this learning type model makes automatic predictions about the interest of a user by collecting her or his or her preferences from many users, meaning users of similar types will be profiled. And based upon the profile, the system will recommend what this particular user will prefer if this user is profiled under a particular group from which the preferences are selected. And the other one is user-based under collaborative filtering. There is something called user-based collaborative filtering, wherein a user gets recommended the contents based on the preferences of users who are similar to the target user. And next comes the item-based collaborative filtering. So in this kind of filtering, the user gets recommended for the items that are similar to those that of target users interest types. And next comes the content based filtering, wherein user gets recommended contents, maybe movies or documentaries, based on his past watch history on the content, be it review ratings or making comments to a particular genre of documentaries or movies. So these are quite a few examples for auto recommenders. And there are some prominent mundane examples wherein auto recommenders algorithms gets applied. One is on, as we all know, streaming services where the content recommendations, as I discussed a few seconds ago, are good examples. And we know platforms like Netflix or Spotify use machine learning to recommend movies, TV shows, or music based on users' viewing or listening history. So this keeps users engaged and helps discover new content of their choice and interest. And social media, also one of the areas where this auto recommenders gets applied immensely. There's something called friend and content recommendation, in which Social media platforms employ recommender systems to suggest new friends, connections, indirect connections, and relevant content to users based on their interest, interactions, and network. No doubt, Facebook is a great example for this for this example. And then comes the online advertising, and we all might have come across targeted advertisements based upon our purchase history or based upon our interest history. We might have seen advertisement platforms using machine learning to analyze user behavior and preferences to display targeted advertisements. This increases the obviously likelihood of users engaging with advertisements. Another interesting and prominent example would be job portals. We all might have seen job recommendations. Platforms like LinkedIn or Indeed analyze users' skills, area of expertise, experience, and job history to recommend relevant job opportunities. This helps job seekers to find suitable employment options in a place of their choice. So this is about auto recommenders, and next comes the dimensionality reduction algorithm under unsupervised learning part. So this kind of algorithm determines while data set could be having variety of features or variables, all of those features or variables might not be having real influence over the data set, or only less variables are correlated to each other or to the output itself. Few features may look as prominent variables but still might not be influencing or impacting the data set itself. So, a good example would be a real estate field wherein homes in certain parts or in most prominent parts might be cost in a higher range, while the real estate owner might have posted a lot of features and advantages of buying the home in that particular part. It might be true that out of those 20 or 30 features, only 10 features or parameters of that real estate might be contributing to the price. Right? The owner might say he's having a backyard swimming pool, or he might be saying that his home is having a bigger backyard or front yard, or he's having groceries stores nearby, or entertaining enterprising places nearby, or he could be claiming that his rooms are of are of bigger sizes, and he's having additional car garage and storage area. Right, while he could be having many features attributing to the price, but essentially, if it's a cold place, nobody worries about swimming pool being placed out in the back of the home, and people might not prefer having a bigger front yard in few places, considering privacy. So for a buyer, it's not a variable of price influence, or he don't want to see that particular feature attributing to the higher prices. So he or she might ending up in negotiating over the price based upon The preferences are based upon the variables that doesn't have any influence over his interest on the property. So this is quite a good example for dimensionality reduction algorithm, which comes under unsupervised learning. So these are quite a few learning types, algorithm types within unsupervised learning model.